All right, we are back with a quick follow-up to the previous episode, sub-episode. I don't know what you want to call it. So there were a couple of things that we wanted to follow up on from episode 8, the Elysian Kingdom. One of the things that came up in the discussion of that was that the crew makes mention when they find the nebula, I guess is the right word, that perhaps it's a Holtzmann brain, and neither one of us knew really what that was.
Was it Holtzmann or Boltzmann?
I thought it was Holtzmann with an H.
It's Boltzmann with a B.
Oh, okay. I did some... clearly, I don't even have a good memory. I looked up the right thing, I'm sure.
Yeah.
So a Boltzmann brain it was a thought experiment that came out in the late 1800s. So this is not a recent thing.
So it's some trust fund kids talking in a coffee house.
Yeah, that's kind of what it is. Did you look any of it up?
No, but anytime you say thought experiment, that's where my mind goes.
So again, this is a thought experiment in the late 1800s. And ultimately what the Boltzmann brain is they are making mention of how complicated the universe has to be for you to be here right now. You know, how many ancestors do you have to have and meet that create you? How many, atoms and planets and...
Yeah, I mean, we're all made of parts of exploded stars, so
basically, the conclusion is that for me to be sitting here talking to you on this microphone took 10 bajillion coincidences to happen for me to be here. And apparently, the Boltzmann brain was a thought experiment about it's actually more likely for a completely random set of particles to form in space and form a human brain complete with the memories of a full lifetime than it is for the universe to align in the exact way that it did for me to be where I am today. So it's not necessarily about a consciousness or an entity. It's more of an experiment in numbers, in probability. It just happens to be about a brain forming in the middle of nowhere. And there was what I saw was the likelihood of a Boltzmann brain forming, like they had done the math. And again, this is just random particles colliding and forming in the middle of nowhere that happens to form a human brain with memories, was, if I remember right, it was 10 to the 10th power to the 50th power. So clearly, I mean, like, the odds are completely stacked against this ever happening, but it's so much more mathematically probable for that to happen than the universe to align the way that it is right now. So it's kind of strange that number one, that's an extremely obscure reference.
Yeah, it's weird that anyone wrote this down.
Well, I mean, I'm kind of a science nerd and I've never heard of this before. So here we are, what are we in Strange New Worlds? Are we in the 24th century?
Yeah, no, we're before that, but I'd have to look. I'm not sure exactly.
We're 200 or 300 years in the future, and I really don't feel like people at 200 or 300 years in the future are going to remember the Boltzmann brain because it's such a weird concept.
Right.
But just wanted to do a little deep dive on that. It did come up in that episode.
This is a crime that Star Trek commits pretty often, where the people living in that time have some very apropos 20th century references at hand. They'll make reference to things, casually make reference to things that occurred in the 20th century.
Right. It happens all the time. I mean, like, you could argue that Sherlock Holmes is relatively famous, but fast forward 400 years in the future when they're on the holodeck, are people really going to be talking about Sherlock Holmes?
I mean, maybe, because Sherlock Holmes is pretty big in the canon. I mean, there's been all kinds of, how many times has that story been told? So that one I don't have a problem with. But yeah, like this like thought experiment that happened in the 1800s, this is going to be common knowledge in the, I mean, I guess it's, Hemmer mentions it. Mbenga says, yeah, I think I heard something about this, but I don't really remember what it was about. So it wasn't something that they're like, oh yeah, the Boltzmann brain. We all know about that. That's in chapter 3 of the philosophy course we all take at the academy. I mean, they weren't all familiar with it, but yeah, Hemmer knows this for some reason. Why?
Right. Yeah, Emmer knew it and the doctor didn't.
Right.
Anyway, the point, I just wanted to circle back on that because I thought
maybe Boltzmann is huge on Andoria. Like he's
right. I mean, the Boltzmann brain has a pretty serious Wikipedia page. I mean, there's a lot has gone into this, so I suppose it's possible that they would know about it in the future, but I find it slightly improbable just because it's not the most appropriate to traveling around in space, so to speak.
Right.
The other thing that I wanted to talk about that we didn't really know a whole lot about was exactly how the warp drive works. Do you want to talk about that?
Well, I mean, let's not say didn't know, more like didn't want to admit to. How about that?
All right. Okay.
Or just didn't think it was important getting into the nitty gritty of that in during the podcast. But no, I mean, the warp drive it's a theoretical concept that didn't originate with Star Trek. It had appeared in some science fiction prior to that. And it's based on some theoretical physics. So, I mean, there's some hand waviness going on, but there are some actual principles that it's based on. And again, I think that's probably mostly due to the fact that it existed prior to Star Trek, because Star Trek just makes stuff up if they need to. But in this case, they lifted something that a harder science fiction author had come up with already.
So just to clarify what we're talking about. So science has proven, I mean, that's ultimately what E equals MC squared is that no object or particle can travel at the speed of light.
And that is the speed limit.
It will require essentially infinite energy to push yourself to go that fast. So that is the fastest that anything in the known universe can go. And even though Star Trek is a fiction show and, there's aliens and phasers and transporters, they are still beholden, at least in this universe, to the speed of light.
Right.
For storytelling purposes, they need a way around that because space is just plain big and empty. And if, we just could go a fraction of the speed of light, most of Star Trek would be just watching, black screen or the occasional star flight.
Right. Well, and they also need for there to be a reason that the Enterprise is transporting, these energy modules to Starbase, whatever. Because if they were traveling at the speed of light, not only would it take hundreds or thousands of years for them to get there, but it would be, thousands or tens of thousands of years on the space station before they arrived. So relativity would be a big problem.
Yes, absolutely.
And so they solve both of those things with warp drive. Basically, warp drive is the idea that you are creating a bubble around the ship using a very high-powered energy source to warp space-time such that the speed of light is no longer in effect. The speed limit is not in effect, so that light will travel faster than it normally would. So the speed of light is still the speed limit, but now light will move faster in this bubble.
Right. And I didn't realize, I'd never put two and two together until I started looking it up, that's why it's called the warp drive, because it, like you said, it warps both space and time. It changes the rules. And none of that is explained how they do that, and that's fine. They just make mention that is how they get around this limit, is that they change the rules of things that apply to how objects are allowed to travel. And so that's why it's called the warp drive and not the I don't know, the
hyperdrive or whatever they call from Star Wars. It's in this case, they're, like you said, they're changing the rules. Okay, the rules say we can't go faster. Well, then we got to change the rules.
So they come up with a science-ish way to get around this.
Yeah,
and they stick to that. And, they're pretty good about that in, I think, all of the Star Trek episodes or series. It's my understanding, and I just want to clarify this for myself. Warp 1 is the speed of light. Is that right?
That is right.
And then I believe warp 2 is 10 times warp 1.
Yeah, it goes up logarithmically basically from there.
So warp 3 is 100 times the speed of light, and it goes up significantly from there. And the theoretical max in any of the Star Trek universes is warp 10. I don't know why they chose warp 10, if there's something specific about that.
Well, they just wanted 10 to be the highest, basically. So
there's one episode of Voyager where they actually do hit warp 10, and it causes all kinds of problems. So it's very uncommon. You see, I mean, most of I think even in TNG, doesn't they kind of max out at like warp 9, right?
Yeah, they basically the amount of energy required, again, it's exponential. So we've moved the speed limit, but there still is one, and now at warp 10 you're getting up to where it's getting to the exponential energy required again. So that's why they say, okay, warp 10 is the highest, but it's not possible to hit it because you need infinite energy to be able to move that fast.
I forget the particular episode. I don't remember the plot, but what they say, what happens in Voyager when they hit warp 10 is that Voyager actually exists in every point in space at the same time. So it actually ends up breaking physics because the Enterprise is in more than one place at one time.
Right.
I mean, and that's the episode where I think Tom Paris and Janeway turn into lizards, and then they have egg.
They have this whole gets really, really wacky real quick.
And then the only other thing I want to talk about with relation to the warp drive is what powers the warp drive, right? It's the dilithium crystals, right?
Yeah, and they have a matter antimatter reaction, so which is a thing that part's again I mean, it's theoretical, but it's pretty well documented theory that you could have matter and antimatter colliding would generate an awful lot of energy. Much like smashing two atoms together with nuclear fusion lets out tons of energy, having matter and antimatter come into contact would also do that. And rather explosively, potentially. That's why, when the warp core breach happens, that creates this massive explosion, is because if that reaction isn't contained, then it cascades and everything blows up.
What powered the original series? Were there dilithium crystals back in the original series?
Yeah. And dilithium is that's like a made up thing. But it's whatever material they're using to create this matter antimatter reaction is these dilithium crystals. So
are there I'm trying to remember. Are there dilithium crystals in Next Generation?
They mention it, yeah.
Do they?
Yeah.
Because one of the articles I was looking up was talking about the power source, and dilithium crystals came up several times. That's come up multiple times. But that's not the only type. It's not like fusion where there's only really one way to do it. They make mention in Discovery that there's a spore drive. It's actually a biological life form that allows them to travel faster than the speed of light. I think it was the J.J. Abrams Star Trek. They had that red antimatter, I think.
Something like that, yeah. They've changed it up a bunch of times.
Just to keep it interesting, it's not always the same thing, and it's not always matter antimatter. But
there's mention in that the Romulans have a different way of doing it, and the Klingons have a different way of doing it. So
anyway, so I just wanted to clear up what warp drive is and what the warp system is as far as how fast it is. So, I mean, when they do talk about going, I mean, I think it's pretty average or normal. They cruise at, warp 7, warp 8 kind of thing.
Yeah.
If you do the math on that, I'm going to do the math in my head. I mean, if each one is 10 times more than the previous, you're I think warp 8, that makes it 1 billion times faster than the speed of light, and that's really, really fast.
Well, and they have to do that to make the show work, where, hey, we're going to go from this one system to another in a couple hours. They've got to do that. They have to be able to move at those speeds.
Right.
It's a pretty good system. I mean, it lets them get away with not having to worry about relativity, which is important, and it lets them go at the speeds they need to, but not so fast that they can cross the galaxy in a day. So it keeps the galaxy big. It keeps space mysterious. Whereas in Star Wars, it's we're gonna fly across the galaxy in a couple of days or whatever it is. It makes the galaxy feel pretty small. In Star Trek, it feels a lot bigger.
You definitely get that impression in Voyager because they are, I forget, at the beginning, they're 77 years when they get sent to the Delta Quadrant.
Yeah.
They're 77 years. I think they say something like if we travel at top
maximum
warp
warp, yeah.
we're 77 years away, and that's a pretty decent ship traveling at rather high speeds. So
yeah, so it's a good system for them because again they can get to Starbase 9 in 5 hours, but then it's also years to get across the galaxy.
Well, I like that, there are rules and they break those rules, but they break them in a very consistent way. They don't just say, oh, hey, we figured out this new fancy thing and, now these rules don't apply. The rules still apply. We're just changing the rules essentially. So it's a creative way around an actual scientific problem.
Yeah, and it's theoretically possible. So
yeah, I mean, looking on Wikipedia, if I look up warp drive, there's an entire Wikipedia page that has very little to do with Star Trek. I mean, there's Star Trek on here, but yeah, you're right. This whole concept, it says the general concept of warp drive was introduced by John W. Campbell in 1957. So, yeah, I mean, this has been around for a while, so that's cool.
Yeah.
All right, there's a few things I wanted to cover because
we've admitted to our nerd crimes.
We didn't sound like nearly enough nerds on that last episode, so I want to
totally.
All right, I'm gonna go clean my pocket protector now. We'll be back probably next week.
You don't have like 3 of them on standby like I do?
You just have my first pocket protector's in the wash. Let me get out the back while that one's cleaned. Yeah. Okay.
Yeah, you gotta have a wash day pocket protector.
Oh my gosh. All right, that's all I got.
All righty.